Can you explain a little bit about who you are, your role, and where you work?
Sure. So I'm Sai Sandeep Ogeti, a cloud and DevOps expert with over 12 years of experience in the IT industry. I specialize in managing cloud platforms such as like AWS, Azure, and GCP, and have like a strong background in CI/CD automation and cloud security. In my role currently as like a technical lead for the cloud and DevOps engineering at Fidelity Investments, I lead initiatives to build scalable and secure cloud infrastructure solutions. I'm also the founder and the organization of the Research Triangle Meetup Group, fostering a community of like over 3,300 members in the Raleigh-Durham area.
What are three emerging Kubernetes tools that you're keeping an eye on?
I'm keeping an eye on especially on Kubernetes and also especially with the open telemetry. This is also like related to like the platform streaming. And the third one that I always wonder is on like tools that can help managing your automation, like connecting to the clusters, which is another area that I always feel challenging because like we deal with a lot of clusters like Google clusters, Amazon clusters, or Microsoft Azure clusters. So having a tool to connect to the clusters immediately with like one single command is something I always look up for solutions and tools that can help my day-to-day life ease.
And we've been talking about platform engineering for a while. It's got a lot of traction in the space. In terms of working at a large scale financial institution, you're working with different clouds. What are some of the challenges that platform engineers are facing on a day-to-day basis?
So especially, I would say, especially on the cost optimization, why is like I'll give an example and I'll tell like how this is like most emerging like topic for like platform engineers. So bridging the gap, like the knowledge gap for the developers who aren't like Kubernetes experts is crucial for like organizations aiming to optimize their like pod level configurations effectively. And also once like the effective strategy is to establish like a centralized team of Kubernetes specialists, and this also dedicated group can manage the configuration and operation of Kubernetes clusters, providing support and acting as internal consultants for like development teams. By centralizing expertise, like organizations reduce the necessity for like every developer to become like a Kubernetes expert, allowing them to focus on like application development while relying on the specialized team for like Kubernetes related tasks. And another approach that I always think is like involving fostering cross-functional collaboration, encouraging knowledge sharing between like traditional developers and also the operations professionals help create like a more holistic understanding of systems in place, and building teams that also can effectively communicate complex technical concepts across like the departments, and also promotes like a DevOps culture, breaking down soils and fostering innovations through open communication and sharing the responsibilities. So additionally, like one last thing is implementing tools that provide the best practices, automation, and also safeguards and assist in bridging the skill gap. Such tools allows teams to learn for like a manageable pace while reducing the risk innovations and also associated with the lack of expertise. So by adopting these strategies, organizations can effectively bridge the knowledge gap, enabling the developers to handle pod level optimizations confidently. And also this also enhance like cost effectively, but also fostering like a culture of on like a continuous learning and collaboration, driving the innovation, operational excellence within the organization.
We on the subject specifically of clouds, we've seen or we've heard in different conversations about people in the last few years moving away from the cloud. Is that something that's going on in Fidelity, running more workloads on-prem?
No, actually, because we do have pretty good solid footprint both in like on-prem and also cloud, and we have on-premise as well, and we actually have like an internal tool that we build where we can spin up like on-prem cloud, and a lot of applications that are compliance that has to be like in the on-premise, we're still are treating as a cloud. And the only difference is like we manage our own cloud. It's not like any public CSP like Amazon or any AWS or Azure. And the good thing about is like with my experience with Fidelity, like regardless of which technology stack you are in, like on-prem, or you're working like a traditional on-premise person, or like a cloud engineer, the roles and responsibilities are getting similar regardless of who you are like earlier, like even if you're like a traditional developer or like a cloud engineer who's who brings a lot of expertise. You are working with both clouds, like both CSPs. Like we are building like a hybrid cloud, which is going to help like for both traditional operations team or the latest the cloud engineers emerging technologies team. So it's getting both similar.
And you mentioned earlier on talking about open telemetry. In your experience, we've seen a lot of tools coming out in the observability space, but also it's no secret that for Kubernetes there are tons of tools, and sometimes tools for tools and dashboards for dashboards. What have you done in your work to try to avoid tool sprawl?
I would say, like I will really take an example, like everybody in the organization, not just us, like we are moving towards like open source technologies, open source tools, and we're actually cutting down a lot of tools. And we used to have like number of tools based upon my experience within the organizations. Like I've been in fintech, I've been in like retail space, telecom space. With my experience, like each team operates like as a business unit, and they have their own set of tools. Like let's say if a organization or a business unit uses Splunk, the other organization uses like Elastic Search, or like a ELK stack or anything. So with open source going, I think everybody's adopting a lot. And open telemetry is something that every organization is trying to build their own set of instance, and feeding the data from like Prometheus or any other data metrics to telemetry. And everybody is adopting open telemetry these days, because I'm speaking with a lot of industry leaders, like with my community groups, and they often tell like they're going towards the open source technologies, and open telemetry is something they are actually taking like a monitoring stack for the organization. And yeah, a lot of on like open source technologies are getting emerged. And with that, I think everybody's trying to move towards the open source. Not that like the SaaS products or something is going down. It's like emerging, right? Like with a lot of open source that's out there, I think people wanted to try, and there are like a lot of scenarios that they want to explore. Like I would say one example is if an organization says like, hey, we'll use open source, but the leaders are questioning about like, what about like SLAs and SLOs? Like what if like something, a feature working in production is down, and who's going to be responsible for this? So those things are, I think the leaders are taking like a keen interest in trying to see if they can address that. But apart from that, I think everybody is trying to use like open source tools, like open telemetry or like any other open source tool.
Great answer so far, by the way. Fantastic. And now let's get into the three questions that we spoke about earlier. So if we're talking about stateful applications and databases, one of our guests, Paul, argued, we don't store state in Kubernetes because as long as you can treat Kubernetes as stateless, it's a nice abstraction and assumption to use for day-to-day management. How do you manage stateful apps in your Kubernetes clusters?
So managing stateful applications in Kubernetes requires like a strategic approach to ensure like a data presence and also the reliability. Kubernetes, traditionally designed for like stateless workloads, has evolved nowadays to support like stateful applications through like features like stateful sets, PVCs like the persistent volumes, and PVCs like persistent volume claims. And stateful sets are like essential for deploying stateful applications, as they provide each pod with like a unique identity and stable storage, ensuring consistent data even as like a pods are rescheduled. This is particularly important for applications like databases, in example, and where like data persistence is crucial. So the PBs and PVCs facilitate the dynamic storage management, allowing the applications to maintain state across the restarts. Whenever the pod restart, it has to maintain that state. And by defining the PVCs like within the stateful sets, each pod can be associated with its own storage, ensuring the data persistence across pod rescheduling or restarts. And also implementing a headless services in conjunction with stateful sets allows for like stable network identities, enabling each pod to have like a consistent DNS endpoint. And this setup is particularly beneficial for like distributed databases and also other stateful services that rely on state network identities. So additionally, like following the best practices, like separating the stateful components from like a stateless ones, and using appropriate storage solutions based upon specific use cases, and implementing the backup and disaster recovery solutions are crucial for like effective maintaining stateful applications in Kubernetes. And by leveraging, I think all these features and the best practices, it's possible to effectively manage the stateful applications.
Also, I'd like to note on the subject, running stateful workloads on Kubernetes, something I have a decent background in from running a community focused on that topic. What's your experience been with operators on Kubernetes, particularly looking at running stateful workloads, databases, etc.?
So yeah, that's a great question. Right? So operators are really essential for like any huge workload management, like any organizations who are lifting that workloads in production especially. So operators can be really handy. Like you can customize the operator based upon how the behavior you want. And I've seen over the past, like with my experience, like every organizations or every teams are building their own operators for the use cases, whatever it is. Like let's say you want to schedule some jobs, like you want to run some batch jobs, or you want to you want like specific features that is not supported within like the community like AWS or Kubernetes. You can bring your build your operators. And operators are key in any team who are like managing their workloads more effectively, and they can customize their deployment or applications or any scalability efforts. And I have seen like many teams are moving not to build their operators because of the technology lag. But I think nowadays what I've seen with a lot of learning and development days, they are actually trying to learn to build their operators, and I'm actually mentoring a lot of teams to write the operators within the organization for their specific use cases.
On the subject of platform engineering, specifically cost optimization, one of our guests, Kenzay, suggested that developers should ideally handle pod level optimization, such as setting requests, limits, etc. How can organizations bridge the knowledge gap for developers who aren't Kubernetes experts?
Okay, that's actually a great question. But to be honest, like so cost optimization, especially at the pod level, refers to like to practice of minimizing the cost of running individual Kubernetes pods by carefully managing their resource allocation, primarily by adjusting the number of CPU cores and also the memory assigned to each pod based upon the actual usage, ensuring you only pay for like the resources what you've used and your application truly need. And often achieved through techniques like auto scaling is one of the techniques, and also resource limits and request. And if you set like a right set of limits on the resources, like for the deployment of the application, it's also like well achievable. And also right sizing your instances, you have to keep a eye closely on the cost that you're running towards your clusters, and try to see if you have like any pods or instances that are not using as much as you defined. When I mean that, like let's say you have like an application running with like eight vCPUs and like 20 gigabytes, and you have like a stable application just running using just only 20% of it. You have to keep a close eye on it, and or you can create some alerts, like alerting when you're not using up to the threshold, right? And you have to right size the limits and you have to reset that, or else I think the cost is going to go up, it's not going to go down. Another like key point is like spot instances. And instances is also like utilizing the cloud provider, like discounting prices, and also you can actually pay less price because you have that instance up and running only for when you need it. You don't have to spin up that instance and up and running 24 by 7. So another technique that I've seen is always like try to monitor and analysis. Like you have tools such as like Kubecast is one of the pretty good tool out in the market. A lot of FinOps organizations are using, and also you can use different tools like Datadog, and also can you give you like a holistic approach on your cost optimization. But I think try to use like external tools like also one other tool that I can remember is Apptio. The cloudability is also like a solid tool that gives you like what's been used in your clusters and what's been ideal, and you can resize your clusters. By doing this, I think you'll get a solid understanding on like cutting down the cost. We have did the same drill like within our organization, and we have cut down the cost like up to like 30%, and we are doing it over and over. It's like every month effort. Like it's not like a once in a while, or like do once and forget about it. It's something you have to keep it consistent so that you can maintain that cost stability, like going downwards instead of going upwards.
On the subject of observability and monitoring, our guest Miguel explained that while monitoring deals with problems that we can anticipate, for example, a disk running out of space, observability goes beyond that and addresses questions you didn't even know you needed to ask. Does this statement match your experience in adopting observability in your stack?
With my experience, right, adopting observability within like our technology stack has significantly enhanced our ability to understand and manage complex systems, right? While traditional monitoring focuses on predefined metrics and alerts to identify as which is known as like a known issues, observability provides like a comprehensive view by collecting and analyzing telemetry data such as logs or metrics or traces, or like to offer insights to the system's internal states. So this approach enhance like us to proactively identify and address like unforeseen issues, improving the system reliability and performance. And also implementing observability has allowed us like to detect anomalies and also like understand the root causes more effectively. For instance, I'll tell an example. Like by analyzing a distributed traces, we've been able to pinpoint the latency issues across the microservices, like the pods which are running in the clusters, leading to more effective troubleshooting and also the cost optimization. So, moreover, like observability has facilitated a more proactive approach to system management by continuously like analyzing the telemetry data. We have been able to anticipate the potential problems before they actually exist, allowing for like timely interventions and managing seamless user experience. So this proactive is a significant advancement over traditional monitoring practices, which often react to issues after they occur. Also, other example that I can think of is like let's say you have a lot to do with like AI and ML ops, the artificial intelligence and also machine learning with operationals. So you can actually create like a bot, where you can deploy. It is like a like a node instance in every node, like a daemon set, and you can make it you can make analyze your applications, whether if you're like going to have like a downtime in your feature, you can actually predict that and alert the engineers before that actually exists. And I've seen leaders are doing this as like a proof of concept, and I think I've seen so far like pretty good results, and I'm amazed like to see how it's going to be emerged. But I think AI and ML ops is going to be like a solid tools for like any engineers, like platform engineers, infrastructure, or like DevOps engineers, for helping their day-to-day life, and analyzing the metrics, whatever the historical data it has, and giving it like hey, you're going to have like a downtime like in so and so time, and take these actions. Those are the things that's going to come. And I've seen that like doing a lot of POCs on these areas as well.
With that in mind, Looking at the next 10 years of Kubernetes, since we celebrated 10 years of Kubernetes in 2024, is you expect more AI and ML to become, a regular part of people's lives. We see tools like, K2GPT. We have the AI working group now in the CNCF. What are other things you expect to happen in the next decade of Kubernetes?
So what I would think is like one of the solid, topics that I think everybody is taking a peek at it is how do you manage your clusters across like multi environments? Let's say you have like 2000 clusters, you have like, for your organization, and you have to have like an isolated environment. And back in the days, I think, I'll take an example that I know of organization who created the Kubernetes clusters like a decade ago. And today, like they're running every workload, even with Windows workloads and, with all the Linux workloads, they're running on Kubernetes. They have like 2000 clusters, and the cost for them for the clusters, especially, any GCP or Azure or AWS clusters, the management node, the cost is at peak, and they're trying to reduce those 2000 clusters to like maybe 400 clusters, and they're taking some of the advancement topics like multi-tenancy, that like how do you isolate the environment within using like Kubernetes concepts instead of creating like a brand new clusters. And multi-tenancy is going to be at peak moving forward. I think a lot of organizations are already doing it, and people, I think organizations will come to this, trying to re-architect their clusters and trying to bring down the cost, especially on the clusters, but especially for the master node. Another other topic, like we just discussed, the AI and ML is going to take a peak. Like it's going to evolve and help you, like to your day to day life. And also, I've seen about the GPTs. Like everybody are building their own GPTs. Let's say if given a chance, I can do like a GPT, like a Chat GPT for Kubernetes, and I try to feed the historical data, and it can be like just links or like any other data source, and feed it to the GPTs, and it's going to give like it's going to be like a go-to tool for like troubleshooting. And a lot of people are doing it. I think what I've seen is, I think organizations like Kubernetes, open source technologies, right, they will come up with any kind of extended GPT for helping, for the developers, and it can instead of like we going and searching like any other different data source, we can rely on that particular GPT, and that's going to be evolved based upon my scenario. And the last one is like also like cost optimization. Like people are taking a lot of steps towards it, because I think the goal back in the days was like maybe like 3-4 years back, the goal was to move towards the a containerization, and now they are in the containerization, and I think they are looking at their design of their applications and trying to see how they can cut the cost. So I've seen that as well, like emerging trend over and over.
When we ask people about their least favorite Kubernetes features, some things that get mentioned are, overall complexity. I think came up earlier in our conversation about the knowledge gap. Another thing, more in the technical sense, people say network policy management. That's something that came up
Yeah.
a lot as, something particularly painful for a lot of folks. Although it seems that some things, talking about gateway, some things are, improving there in terms of new APIs. But in your experience, what would you say is your least favorite Kubernetes feature, the one you would like to see improve the most?
I would say especially on integrating with multi-cloud, and I've not seen any feature that's been out there. Like let's say if I want like I will take a real time example, right, with my experience. So let's say you have a cluster running in AWS, like Kubernetes clusters, and for some reason I think the storage, right, like let's say when compared to AWS S3, you're getting storage less cheaper, in Azure. And if you have like a feature that you can integrate like a add-on feature or something, so that you can talk to your data source sitting in Azure, is something we don't have that feature. We have to do lot of peak at it and also a lot of tweaks. And also network is other crucial in trying to communicate with like different clouds, because the architecture is like from on-prem to cloud and cloud to on-prem, but also, and I think a lot of organizations are moving cloud to cloud connection as well, like the networking, I think, layers. And moving forward, I would love to see, like, regardless of cloud agnostic, the features has to be evolved and talk to like different CSPs. That's something I would like to see like moving forward. And I've seen a lot of use cases. People are using multi-cloud and also like hybrid, for example, like on-prem and also cloud. And regardless of where your cluster sit in, I think you should have like a capability and go on, talk to the different CSPs, which is something really interesting that I want to see in real moving forward.
If people want to get in touch with you, what's the best way to do it?
So I think I'm so active on like LinkedIn, and also like I do a lot of meetup groups. I think people can sign up to my meetup group. I can post a link to Bart, so I can post to the team. I think I do like at least every 2 weeks I try to do a session with like emerging topic, and if people interested, I think they can join and pop up and say hi and speak with me. And also I'm also available on LinkedIn. People can hit me up, and I'm all open to.
Perfect. Well, thank you very much for joining. Looking forward to speak to you in the future. Take care.
Yep. Thank you.